Hello students, Miss Ku here. Today we're going to learn a little bit more on chemical calculations. The focus of today's lesson is to be able to apply the three formulas which we have learned during the previous few lessons to chemical calculation questions using the three-step approach. Aren't you excited? As I go through, do jot down notes, okay? You will need this knowledge for the next few chemistry lessons. Alright, let's get started. Let's take a look at the question. Calculate the volume of the gas obtained at room temperature when 16.8 grams of sodium hydrogen carbonate NaHCO3 is heated strongly until there is no further change. Sodium carbonate, carbon dioxide, and water was produced during the decomposition. It seems like there's a lot of info to digest. Let's try to break it down into parts. Firstly, let's identify the reactants and the products. The reactant for this question will be sodium hydrogen carbonate. So let's highlight it and write the letter R above it to indicate that it is a reactant. What about the products? As we can see, the products of this question are sodium carbonate, carbon dioxide, and water. Likewise, let's write the letter P to indicate that these are the products. Very good. Moving on, we have to write the chemical formulas of the reactants and products to form the chemical equation. Now, let's go back to the question again and identify the values that are given to us. As you can see, we are given 16.8 grams of sodium hydrogen carbonate. So we're going to write that on our chemical equation. So let's write above it 16.8 grams. Alright, and we're going to put the word given. Okay, so this is the value that is given by the question. Next, let's identify what we have to find out. Okay, so going back to the question, it states that we are required to calculate the volume of the gas obtained at room temperature. So if you look at the chemical equation, you will identify that carbon dioxide is the gas. So we're supposed to find the volume, so we're going to write volume and put a question mark, and we're going to write the word find to indicate that we are required to find the volume of carbon dioxide. Alright, so let's answer the question. Okay, step 1. What are we supposed to do? We have to use the given mass and convert it to number of moles. Do you remember which formula we have to use? Yep, that's right. We have to use the number of moles is equals to the mass divided by molar mass. So I'm going to draw the triangle right now to help you to remember. Okay, so that will be mass equals to mole multiplied by molar mass. Okay, so now let's work out the number of moles of sodium hydrogen carbonate. So number of moles of NaHCO3 will be equals to mass of NaHCO3 divided by the molar mass of NaHCO3. Okay, so that will be equals to 16.8 grams. And for the molar mass, we will have to refer to the periodic table to get the values. So let's take a look at the periodic table. So for sodium, the relative atomic mass is 23. For hydrogen, it is 1. Carbon, 12. And oxygen, 16. Okay, so let's apply this value back to the question. So we will have 1 sodium atom, so that's 23, plus 1 hydrogen atom, so that's 1, plus 1 carbon, 12, and 3 oxygen atoms, so that's 3 multiplied by 16. Okay, so we solve this, we will have 16.8 divided by 84, and we will get 0.2 mole. Okay, next, let's move on to step number 2. We are required to compare the mole ratio. So we have to compare the mole ratio of the given and the find. So looking back at the question, the given is sodium hydrogen carbonate, and we're supposed to find carbon dioxide. Okay, so let's write that down. Mole ratio of given is to find. Right, so the given we have NaH, CO3 is to CO2, carbon dioxide. Okay, let's refer back to the chemical equation. Okay, so for the coefficient of sodium hydrogen carbonate is 2 and carbon dioxide is 1. So the ratio of the ratio will be 2:1. Okay, as you remember, in the first step, we found out that there is 0.2 mole of sodium hydrogen carbonate. So let's write that down. So that's 0.2 mole. Okay, so for carbon dioxide, it will be 0.2 divided by 2, and you will get 0.1 mole of carbon dioxide. Okay, good. Now let's move on to the final step. Step 3. In step 3, we are required to find the volume of carbon dioxide. Can you recall which formula we should use? Okay, that's right. We should use volume in dm cube is equals to the number of mole multiplied by 24 dm cube. Okay, so now let's apply this formula. So to find the volume of carbon dioxide in dm cube, I will have to multiply the number of moles of carbon dioxide with 24 dm cube. Okay, so in step 2, we have found out that the number of mole of carbon dioxide is 0.1 mole. So let's write that down. 0.1 multiplied by 24, and we will get 2.4 dm cube. Okay, and we are done. Okay, I hope that you have learned how to apply this 3-step approach. Do try it for other practice questions, and do replay the video or approach any chem teachers if you need extra help. Enjoy practicing!